Serena, what'd you do?
First I multiplied cosine squared times secant squared.
Okay, so you you went like this times this. How did you write that?
Cosine squared over 1 times 1 over cosine squared.
Cosine squared over 1. I didn't put it over 1 times what?
1 over cosine
1 over cosine
squared.
squared. Okay. I'm going to put your 1 in there just because you said it. Okay, she said over 1, so I'll put it over 1. Okay, and then what?
Multiplied the
And got what?
just 1.
Okay, so basically these two cancel out, right? Okay, and that's all over what? This. And what did you do on the bottom? You what?
It just equals 1.
Okay, so you replace sine squared, cosine squared with 1. So this all comes out as 1 over 1. Yeah? Is that what we're supposed to get? Yep, that's it. So she does it all in one. She replaces this with 1 because that's what it is. She takes cosine squared over 1 times 1 over cosine squared, the reciprocal part of it, cancels out the cosines, and she gets 1 on top, 1 on the bottom. She got it. It's 1 over 1. Good? I'm thinking that was pretty easy for most of you, right? Okay. This next slide talks about, on page 380, I didn't put anything on your paper, did I? No, but last year I must have done this. I must have put this stuff in so that I could talk to the students about what this page says. So either you listen to it, and then later you come in and you write your own stuff down, or you don't have to write it down if you don't want to. It says here, when verifying identities, work with one side of the equation at a time. It is often better to work with the what? More complicated side first. Try make the more complicated side smaller, 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 smaller. Boom, you're done. It's 1, because that's what we just did. Part 2 says, look for opportunities to do what? Yeah, guys, never give up on this factoring thing. Factoring is a really big tool. Okay, or what? Add fractions or subtract fractions. Get common denominators. Or maybe you have to square a what? Square a binomial looks like this. Sine of x plus cosine of x squared. I mean, that's what they're telling you when they say square a binomial. Okay, or create what? A monomial, one term. Now, do you know how to do this? I'm trying to give you a hint. Multiply. Ooh, somebody said it by the what? Now nobody will say it. Conjugate, yes. So guys, we're going to do this in one of your slides coming up. So sometimes you want the denominator just to be one term, and it's really easy. Multiply by the conjugate, and you'll see what happens. We're going to do this in about 10 minutes. Step 3 says, look for opportunities to use fundamental identities. Note which functions are in the final expression you want. So guys, if you look in the answer, if the answer has a sign in it, you know you want sign to be on your left side. Sign, this is really critical that you know that sines and cosines pair up well. So try to get things to be sine and cosine. As do what? Secants and tangents pair up well. How come?
They both have sine on
Yeah, well, secant is just 1 over secant is 1 over cosine, and this is
sine over cosine.
sine over cosine. So what happens is sometimes it's easier to multiply them, sometimes it's easier to cancel them out. And then cosecant and cotangents go well together. So try to pair them up a little bit. All right, number 4 says, if the preceding guidelines do not help you, try converting all terms to what? Sine and cosine? I'm sure your algebra 2 teacher told you that. When in doubt, make everything what? Sine and cosine. Just make everything sine, cosine, and then just work it out. You'll see, usually it helps. And then the last step says what? Try something. Even paths that lead to dead ends provide what? Insight. Yeah. Hey guys, a dead end is not a bad thing. You might run into a dead end and go, I can't do anything, and it's not working. Well, it gives you some insight. It tells you what not to do. And that's good insight. I can't do this because I get the wrong answer. So I got to go the other way. Okay? Sometimes you think you're doing the right thing and you just aren't. And I think this is so important. Always try something. Okay? All right, here we go, guys. The first problem is, prove to me that 1 over 1 minus cosine of beta plus 1 over 1 plus cosine of beta is equal to that. So 2 cosecant squared beta. What's your neighbor doing? How's that for a hint? You are adding fractions, correct? Isn't that what it says? Add that to that. Okay. If I'm adding fractions, what else do I need to know? Common denominator, yeah. Okay. Hey, what is the common denominator, Katie? Do you know? Okay. How about if I do this? How about if I go like this to you guys? What's the common denominator in this one?
35.
Why?
5 times 7.
5 times 7 is 35. You know what? That is a way to get a common denominator. It might not be the lowest common denominator, but it is a common denominator. So all you got to do is take that times that to get the common denominator. So what you should be thinking is, my common denominator will be what times what?
1 minus cosine times 1 plus cosine.
Yes, it's just this first denominator times the second denominator, and there it is. That is the common denominator. I don't know what number that is, but it is the common denominator. 1 minus cosine of beta times 1 plus cosine of beta. Okay? Now, okay, so now the question becomes, how do I get this fraction to look like that fraction? I'd have to multiply this binomial times what? 1 plus cosine, yep. But if you say that, Chris, guess what? You got to do it to the top, don't you? Okay, so what is this going to be here? Here. Yeah, 1 plus cosine of beta. That's what it is. Okay. How do you get this fraction to look like that fraction? Multiply it by what? Okay, 1 minus cosine of beta. Do it here. 1 minus cosine of beta. To get this 1, take away cosine of beta. Yes? Okay, how do you add fractions that have common denominators? What do you do? Add the top, then what do you do to the bottom? Keep it the same. They're common denominators. Okay, so keep going. So the bottom doesn't change. Now that's kind of nice. 1 minus cosine of beta times 1 plus cosine of beta. On top, what happens?
Yeah, the ones together.
The 1 plus the 1 makes 2, and the cosine of beta plus negative cosine of beta makes
0.
nothing. They do what?
Cancel.
They cancel out. That's it. That's where I'm at right now. What do I want this to equal? I can't remember the right.
Two cosecant squared.
So 2 cosecant squared of beta.
Oh, it's that one.
Okay. That does not say that.
Well, you have to simplify the denominator,
So simplify the denominator. You mean
like multiplying together.
foil it out. You have to foil it out. And you know what, guys? Doesn't this have the same look as the conjugates? 1 minus cosine of beta, 1 plus cosine of beta. And if it does have that look, it's just first times first, outer times outer, right? Because the inners do what?
Cancel out.
Inner, outer cancel out. Okay, so here's what you get. 2 over 1 times 1.
1.
And then negative cosine times positive cosine is negative cosine squared. It still doesn't look like that. Guys, when I foiled this out, I got this. Doesn't this look familiar?
1 minus cosine squared is sine.
Yeah, guys, this looks like the Pythagorean identity. This is really just what? Sine.
And put at the end.
Sine squared of beta, right? But that still doesn't look like that. How is it going to work? Yeah. What do you think,
So-
Zach?
You simplify since the top is technically it's just 1 over cosine squared, and the top's just times by 2 to get the 2 over the sine squared.
Oh, Zach, sorry.
I've said something else, but
I didn't quite follow you. I'm sorry.
you take the 2 out and just have a 1 on top.
Okay, so you're saying take a 2 out and then rewrite this as this.
Yes.
Would you guys agree that this is really this? And then this 1 over sine squared, isn't that cosecant? So guys, is it working? Yeah, it's working. Hey, you know what I got to tell you? I have to follow your scribble. If I have to follow your scribble, you know what's really nice is if you just do what?
So,
Would you please kind of do one of these little numbers? And that is, draw me some arrows like this goes to this goes to this, okay? And obviously this goes here. Come on. This did not go there, sorry. This went here, then I went to here, then I went to here. Now I'm back here. So just some arrows help me because you won't believe how hard this is to correct. This is one of my biggest nightmares of the year. Correcting trig identities is really tough.
You should do them.
I should do them?
Just skip over them.
Sometimes I agree with you. All right. Are you okay? You didn't say a word. Okay. Prove. Prove this side right here. Prove the left side is truly equal to this side right here. Not easy. This stuff's not easy. It's good. Sophie, what'd you do?
Secant squared minus 1 is tangent.
Okay. Do you guys agree with her? She called that tangent squared. Yes, no?
yes.
Okay. You know, and I know it's dark in here, guys, but you know, secant squared, if you move the 1 over, it's minus 1, which equals tangent squared. She got it. Sophie, what did you do next?
That's how far.
That's as far as you got. Okay. So you see the sine squared and the 1? Doesn't that have the look of this? Sine squared plus cosine squared equals 1. But guys, look what you have. You have sine squared minus 1. You would have to move your 1 this way so that it would say what? Sine squared minus 1 equals, where does your cosine go? Over here. Well, when you move it over there, it becomes what? Negative cosine squared. Sorry, I forgot my axis. Okay. So, what is sine squared minus 1? It's negative what? Cosine squared, yep. There you go. So it wasn't cosine squared, it was negative cosine squared. And now you gotta look. You can't take a tangent times a cosine. They're different trig functions. It's like saying x times y. What are you gonna do to tangent? Yeah, make it sine squared over cosine squared times what? Negative cosine squared over 1. Don't cross multiply. Because you got two fractions. Always top times top, bottom times bottom, but don't do that. What do? You do some canceling before you multiply. This is the same number as this, but when you cross this one out, you get a 1. This one, you get what? You do get negative 1. And negative 1 times sine squared is? Bingo. We got it. We're looking good. That was tricky because you had to know. You had to know it wasn't cosine squared. It was negative cosine squared. Okay? Now this one to me, I don't look at the left side and go, well, that's the harder side. I don't look at the right side and say, that's the harder side. So you got to kind of pick. Which one seems harder to you? I always start with the more difficult side. Left side, yeah. Yeah, multiplying is pretty easy. Things cancel out usually. I go with this side. So let's prove this. Prove this is really this. And you definitely cannot take a cosecant and subtract a sine. So you got to do something. Just so you know, that's what period 5 did. Period 5 just said, well, cosecant of x is just 1 over sine. 1 over sine minus sine. Okay, maybe I can do something here. Anybody figure out a common denominator? And what does it say?
Common denominator is sine.
Yeah, because you take this denominator times this denominator, 1 times sine is sine. You're right, it's just sine. Sine of x, okay. Here's the nice thing about the first one. It's already over sine, don't change it. What do you do to the second one?
Multiply by sine.
Multiply the bottom by sine to get it to look like sine. Multiply the top by sine.
Sine squared.
Sine squared, yeah. Good? Now, you got to know how to subtract fractions. What do you do to the bottom? Keep it the same. Top, you just add or subtract. Well, subtraction leads to this, right? What about the top?
It simplifies to cosine squared.
Everybody agree? 1 minus sine squared is just cosine squared? Okay, All right. We're getting closer to something. Is this working? I want this to be that. How do I get cosine squared over sine to look like that? You can't just write the answer. You can't just say this is this. You can't do that. Say what, Andrew? Take out a cosine? So you're saying, just rewrite this as cosine times cosine? Yeah. Okay, so Andrew says just make cosine squared cosine times cosine over what? Sine. Now, I hope you're looking at this. Oh, it's just cosine over sine. Well, I could just kind of pick it apart, right? What's that? That over that is what? Cotangent of x times cosine of x. And that's exactly what I wanted. I got it.
Good job.
All right. Adding, subtracting fractions is not easy. Okay. Here's the one that's really kind of, yeah, this is the weird one. Now there, I know what I'm doing. I'm taking cosecant minus cotangent. That is subtraction, which I could change these and go get common denominators. But if you look on the left side, guys, what does it say to do? Take sine and do what to it?
Divide it by 1 over.
Divide it by this. Well, I don't know how to do that. Do you? No. But I want you to look up for a second. Look up. See how it says 1 plus cosine? Hey guys, wouldn't it be nice to see a 1 and a cosine squared? Because that's Pythagorean. Here's the trick I was talking about. Whenever you get that, look right here. Multiply the 1 plus cosine by its conjugate and see what happens. 1 plus cosine, 1 what? Minus cosine. Just do it and see what happens. I think you'll be surprised. This is a trick that allows you to get Pythagorean identities involved. So on top, I took sine times 1 minus cosine. On the bottom, these are like conjugates. Again, first gives you 1. I don't have to do outer. I don't have to do inner because they do what? That'd be cosine minus cosine. They cancel out. Why would I do it? Last times last is what? Negative cosine squared. Are you looking on the bottom? You got a 1 and a cosine squared. Guys, this has a Pythagorean look. What do you think that is? On the bottom. Sine squared, isn't it? Yeah, this is just sine squared, isn't it? Okay, well that was nice. I turned that mess on the bottom into just sine squared. On the top, I got a sine minus sine times cosine. You got tools in your tool belt. Take out your tools. One of your tools, your best tool ever is factoring. What do you factor out? Don't they share a sign? Sine times what? 1 minus cosine. Now why would I factor out a sine, guys? Yeah, I can cross out what? Yeah. Hold on. Okay. This sign will cross out with one of the signs, and you'll get this look. Sine of x. On the top, what's left? 1 minus cosine of x. Right? Uh-oh. How does that turn into that? Look, that turn into that.
You gotta change that side into sine and cosine instead of cosecant and cotangent.
Oh, you want me to work here
Yeah.
and go that way?
So if
Okay.
you just work both sides, you can get them.
Where is she? Okay, so what Hannah's saying is, if you get to that point, you get kind of stuck, you don't know what to do. She's telling you guys that you could just turn this into 1 over what? Sine minus
Cosine over sine.
cosine over sine.
Which is 1 minus cosine.
Yeah, so do you see the common denominator? Well, doesn't this right here equal what? That? It does, doesn't it? Now, hang on though. I wasn't going there. Hannah went there and she did it that way. That's cool. But I want to show you this. Oops. I want to show you that I was going to do this. Because you can do it either way. You can do this too. You can take two numbers on top and break them up into what? Two separate fractions. You can go like this, followed by this. You can do that, right? And then say, well, that's this. 1 over sine is cosecant. Cosine over sine is cotangent. It works. I gotta tell you, the only thing I have to know is what you're doing. So you can't just make up stuff and put it on paper. It has to make sense to me. If you're gonna jump, if you're the kind of person that likes to jump 2-3 steps and just go to the answer, I can't accept that. You won't get all the points. You gotta show step by step, and you gotta be very obvious why this equals this. Okay? Now, here's the good news. The good news is, we're done with notes. That's the good news. You want more good news? There's no notes tomorrow, and it's day 2, so what do you think tomorrow is?
Work day.
Simple work day. That's all it is. But wait a minute.